Explain briefly center and saddle critical points. Solution 1. Center definition. The isolated critical point 0, 0 of the autonomous system dx over dt equals to pxy, dy over dt equals to qxy is said to be a center of if there exists a neighborhood of 0, 0 which contains a countable infinite number of closed paths Cn where n equals to 1, 2 and so on, each of which contains 0, 0 in its interior and diameter Cn tends to 0 as n tends to infinity, but 0, 0 is not approached by any of the path either as t tends to plus infinity or t tends to minus infinity, where the diameter of any closed path C is defined to be the maximum of the distance AB on C for all the possible points A, B and C. AB on C. Now figure shows the critical point 0, 0 as the center. It is surrounded by an infinite family of closed paths, members of which are arbitrarily near to the 0, 0, but 0, 0 is not approached by any of the path either as t tends to infinity or t tends to minus infinity. Second, the saddle point definition. The isolated critical point 0, 0 of the autonomous system dx over dt equals to pxy and dy over dt equals to qxy is called a saddle point if there exists a neighborhood of 0, 0 having a following two properties. One, there exist the two paths which approached and enter 0, 0 from opposite directions as t tends to infinity, and there exist two other paths which approach and enter 0, 0 from the different opposite direction as t tends to minus infinity. Second, in each of the four domains between any of the two of the four paths, when there are infinitely many paths which are arbitrarily close to 0, 0 but which do not approach to 0, 0 either as t tends to plus infinity or as t tends to minus infinity. Now figure shows that the critical point 0, 0 as the saddle point, which is first each approached and entered by the two of the half of the line of the paths AO and BO as t tend to infinity. These two paths from the geometric curves AB. Second, approached and entered by the two half of the line paths CO and DO as t tend to infinity, forming the geometric curves CD. In 1 and 2 there are four domains of R1, R2, R3 and R4 where each of these domains contains infinitely family of semi-hyperbolic paths which do not tends to 0, 0 as t tends to infinity or t tends to minus infinity, but which becomes asymptotic to the one of the another of the four half line paths as t tends to plus infinity or t tends to minus infinity. There D, O, C, A, B, R1, R2, R3 and R4. This is X and this is Y axis.